Welcome to this revision tutorial looking at the types of radiation and their properties. Now, when we're talking about what we need to know for GCSE physics and types of radiation, there are three types of radiation that we need to know, as are represented on this diagram here. The names of these three types of radiation are alpha, beta, and gamma radiation. Now, each of these has distinct, unique properties that it's important that we're able to associate with each type of radiation. So, if we start at the very top with alpha radiation. Now, alpha radiation is made up of a particle that consists of two protons and two neutrons. And if we think back to what we know about the charges of protons and neutrons, we know that protons each contain a positive charge and neutrons each are neutral, so have no charge. So overall, alpha particles that are emitted as alpha radiation have a positive 2 charge. Beta particles are otherwise made up of fast-moving electrons. Okay, so they're a single fast-moving electron. Which means that their overall charge is -1. Whereas gamma radiation is often transferred as a wave of energy that's being transferred away from the nucleus. It isn't a particle per se. So the key thing to remember about the different types of radiation is that they are all things that are given out by an atom as it breaks down or decays. Now, in terms of the different types of radiation, there are certain properties that you have to be familiar with and be able to link to the type of radiation. Now, the first thing is the penetrating power of each of these types of radiation. Or in other words, if you put a radioactive atom or particle in front of a substance, what substance is going to stop it from moving? So, first thing to bear in mind is that alpha particles have a low penetrating power, so they can actually be stopped by a sheet of paper. Beta particles have slightly higher penetrating power, so it would take up to 3 mm thickness of aluminium to stop. Whereas gamma are highly penetrating, so it takes thick substances such as lead or concrete to stop gamma radiation from moving. Now, the other property that you have to be familiar with is the range of these particles. So how far can they actually travel? So even more specifically, how far can they actually travel in air? So alpha particles have a range of only up to a few centimeters. They are quite heavy radioactive particles, so therefore can't move particularly very far. Beta have a higher range. They can move a few meters, around a meter in air, whereas gamma, because it's energy that's transferred away from the nucleus, it has a nearly unlimited range. So its range is nearly unlimited. And then the final property, the final property of each of these types of radiation that it's important to be familiar with is what we describe as their ionizing power. So, in other words, their ability to knock electrons out of orbit from other atoms. So if you have a radioactive particle that is nearby a selection of atoms, because that radioactive particle is giving out radiation, that radiation can actually collide with electrons in the atoms of other substances nearby and knock those electrons out of orbit, thus creating ions. That's why it's called an ionizing power. So gamma, because its energy is a wave and it's not got a lot of mass, it's got the lowest ionizing power. Beta has the ability to collide with another electron in orbit, so it's got a relatively higher ionizing power compared to gamma radiation. Whereas alpha particles, because they're the largest, made up of two protons and two neutrons, they've got the ability to knock more than one electron out of orbit, so therefore that actually gives them the highest ionizing power. And those are your three distinct properties of each of the types of radiation. So you have to be able to make sure that you can remember three types of radiation: alpha, beta, and gamma, what they're made of, protons and neutrons, electron or energy, and then their properties. So their unique features. What do they stop by? What are their range in air? So how far can they move in air? And three, what is their ionizing power? What's the ability that they have to be able to knock electrons of other atoms out of orbit? So remember, properties might refer to as unique features. Good. So thank you for watching our brief tutorial looking at types of radiation and their properties.